Welcome to the second video for the Math Review Homework 1 answers. We're on the second page now. We're going to work through this one a little bit quicker. Got a mark down here still. So, first of all, we want to write all these decimals that were given in scientific notation. So basically we need to identify what magnitude or order of magnitude we need to multiply our base numbers by, right? We have 4.5 base number times something, 2,430,000, which is 2.43 base number times something, and 1.1 base number times something, right? So we need to figure out what those 10 to the somethings are. So over here I can look, I have a decimal and then I have the tens, hundreds, thousandths place. So the 4 is in the thousandths place. And when I've got it over here as my base for my scientific notation, that indicates to me that I need to multiply by 1,000th, right, to have this conversion be correct. So it'll be 4.5 times 10 to the negative third, right? 10 to the third is 1,000. 10 cubed is 1,000. 10 to the negative third is 1,000th. Next one, so 2,430,000. Our base number is 2.43. The 2 is, we've got a million right here, we're in the millions. And our factor, our order of magnitude for a million is 10 to the 6th. So our 2 is in the millions place. Our 2 over here is our leading number, so that indicates to us we need times 10 to the 6th. It's about 6. And the last one, part C here on the top line, the point of this one, right, here let me, this first one becomes this 1. And so we need, it was in the tenths place, and so that means that we need times 10 to the negative 1, which is a tenth, right, 0.1. Down here, let's see, these are a little bit less intuitive. So 82.4 and then funny thing m. This funny thing is a mu. It's a Greek letter mu. So this is, and it stands for micro. So this is micrometers. And micro, if you look at your reference table, means a millionth. So 1/1,000,000th of something. So we have 82.4 times 10 to the negative 6 for millionth. Now, if we want to write that, you could also write that in really proper scientific notation, have just one number before the decimal. That'd be 8.24 times 10 to the negative 5th. All right, just drop one of my orders of magnitude because I moved my decimal over. Same thing down here pretty much. So we've got 321 ns. The s is seconds, the n is nano. So this is nanoseconds. If we look in our reference tables, nano is a billionth, which is 10 to the negative 9th. So we have 321 times 10 to the negative 9th. And that one in proper scientific notation will be 3.21 times 10 to the negative 7th. Right up here, I moved my decimal one spot. So I went from negative 6 to negative 5. Here I moved in this decimal that's not explicitly written, but there's like a decimal right here, moved it 2. So I lost 2 orders of magnitude, or I went up 2 orders of magnitude here, right, from 9 to 7. All right, let's see, number 2. Compute the following. Note that 5e to the negative 2 is a shorthand way of writing 5 times 10 to the negative 2. Okay, so let's take a look at this. The e, which could also be, you'll see, as like right up here, EE in your calculator. E is a shorthand way of writing 10 times 10 to the something. Okay, so that's all E or EE means, times 10 to the something, right? And the something is up here, and this is the something, the 2, right? And over here, here's that negative 2, something. So E, shorthand way of writing 5 times 10 to the negative 2. Express all these in scientific notation. So we've got to do a little bit of multiplication. 3.4 E4 means 3.4 times 10 to the 4th times 5.6 times 10 to the negative 3rd. Now this is an interesting point. This was something that people made quite a few mistakes on. So let's work through this one a little bit explicitly. When I multiply, let me write this out. This is 3.4 times 10 to the fourth. I'm just going to write it out explicitly for this one. Times 5.6 times 10 to the negative third. When I multiply numbers with exponents, the exponents do not multiply. The exponents get added. So what I do is I do normal multiplication for my 3.4 and my 5.6, and then I keep my times 10 to the something for my answer, and then my exponents get added, not multiplied. So if I do 3.4 times 5.6, that's 19.04. Let me write that over here, 19.04. And we'll just treat it like it's 19 because the 0.04 is tiny. We'll round it, right? And so that's going to be our base number, 19. And then times 10 to the fourth, 10 to the fourth times 10 to the negative 3. I'm going to do 4 plus negative 3, which gives me 10 to the 1. But to put it in proper scientific notation, I would need 1.9 times 10 squared, right? So this is our answer here. So the thing that's important there is that when you multiply numbers with exponents, the exponents get added, not multiplied. Now the same thing is true. There's a similar rule for dividing. When I divide, the exponents don't get divided over here. They're going to get subtracted. So this is going to be, right, I'm going to do 10 to the third divided by 10 to the negative third, and what I'll do is 3 minus negative 3, which gives me a positive 6. So if you do this whole thing out, it's going to come out to 5 about, right? Some of these are going to be a little bit rounded. 5 times 10 to the fifth. It was the sixth, but if you figure out that you do the multiplication of the base numbers, you'll have to move a decimal over, and you'll get to the fifth for your final answer. Okay, this last one is going to be a couple steps, right? So we've got a number here that is in scientific notation and then squared, and then we've got a regular, just plain scientific notation number. So if I square something with an exponent, so let's write this one out too. 9 times 10 to the negative 15th, and it's all squared. If I square an exponent of another number, those numbers multiply. So if I multiply exponents, they add, but if I square exponents, they get multiplied. So that's actually going to be 2 times negative 15, right? So this one over here is 9 really, right? It's really 9 times 10 to the negative 30. And if I do the whole thing out, it'll be negative 30, right? 10 to the negative 30 times 10, this e, 10 to the 20. So I'll do negative 30 plus 20, and then the final answer will end up being 8.9 times 10 to the negative 9th. Again, because our base numbers are we're gonna need to move the decimal and lose an order of magnitude there. Okay, D. So 4.6 times 10 to the negative 2 divided by 2.3 times 10 to the negative 8. If I do that out, I get 2 times 10 to the 6th. E, let's see, so we've got 5 centimeters and 10 centimeters. But the thing to note here is we've got, let's pick a different color here a second. We've got centimeters for our numbers that we're doing a calculation with, but we want an answer in meters squared. So you could get something in centimeters squared and then try to convert it to that, but it's actually going to probably cause you to do more work. So the easier thing, and we've got our hint here, convert these centimeters into meters before we do any of our math so that our answer comes out with the right units. So if I convert 5 centimeters and 10 centimeters into meters, it's going to be 0.05, yeah, 0.05 centimeters times 0.1 centimeters, and that's going to come out to 0.005 meters squared, right? Oop, excuse me, this is a mistake, not centimeters. Meters, right? I converted centimeters to meters, Okay, 0.005 meters squared. So last letter here, F, 0.234 kilograms divided by 120 centimeters. Now I want my answer in grams per meter. So I've got kilograms and centimeters, but I want grams and meters. So we have to convert both of those. And we've got the hint again, change the prefixes of the numbers first, right? So if I've got 0.234 kilograms, that's going to be 234 grams divided by 120 centimeters. In every meter there's 100 centimeters, right? So if I had 100 centimeters, this would be 1 meter. I have 120 centimeters, so this is 1.2 meters. And that comes out to 195 grams per meter. All right, last problem here. If the mass of a proton is 1.6 times 10, right, E times 10 to the negative 27 kilograms, and an electron is 9 times 10 to the negative 31 kilograms, what's the ratio of the mass of the proton to that of the electron, right? And we've got the hint. Ratio means divide the two values and expresses a decimal. Ratio is always a division, right? And it says ratio of the mass of the proton to that of the electron. So we're going to do 1.67 times 10 to the negative 27th kilograms divided by 9.0 times 10 to the negative 31 kilograms. My units cancel because I'm getting a ratio here, and I'll use my approximate sign because this is going to be approximate. This comes out to about 1.85 times 10 to the negative third as my ratio. And that's the end of our second page.